Good morning, students. So far in last class, we have to start with the third unit, bring to the classification. So now in today's class, we have to discuss with that decision tree algorithm. And decision tree algorithm, how we can apply it for the various attributes. That is the best case we have to represent. That is the decision tree algorithm, how we can generate the decision trees. So first one, in the decision tree algorithm, mainly we have to use it for the to generate the decision trees. Here you can use the generate the decision tree from the training tuples of the data partition D. So here you have to giving the input for that attribute list and attribute selection methods, splitting point and splitting subsets. We have to give an input and data partition D. So you are using these attributes and methods and data partitions. You can generate the decision tree. So by using this method, first creating the node and if tuples in D all in same class C, return n if node labeled with the class C. So all the tuples in the data partition all are in same class only. So here we can by using the attribute selection method. So best splitting criterion we have to apply it here. You can get the you can generate the decision tree. So by using the attribute selection method, if the splitting attribute is discrete valued, or you can use the other value, and multiple splits are allowed. Then you have to getting the attribute list and splitting attributes. Removing the splitting attribute here, and we have to store it into the attribute list. So like this way, you have to process. Finally, you can get the decision tree you have to generate it. So once the decision tree you have to generate it, how these methods are selecting best test conditions you have to apply. Decision tree induction algorithms must provide a method for the expressing an attribute test condition and its corresponding outcomes for the different attribute types. So here, first one you have to consider the binary attributes. The test condition for the binary attribute generates the two potential outcomes. So here you have to see body temperatures like warm-blooded and cold-blooded. So generally here only whenever you are using the binary attributes, only two outcomes are you are getting. either true or false. That is the test condition you have to apply, selecting the best test condition you have to apply here. That is the binary attributes. So jet body temperature you have to represent it with the either true or false, that is the warm blooded or cold blooded. Another type of attribute method you have to use it for the best test conditions. Here you have the many ways. They can represent it in two ways, multi-way split and binary split. Multi-way split we have to represent. So, for example, marital status of a particular person. So, most of the people they are single, divorced, and married people are there. So, in marital status, you have to represent it as a single, or divorced, or married. So here more than two you have that you have to represent it a multi-way split. So marital status is an attribute that you have to represent it. You have the many values: single, divorced, married, like this. Okay. For example, you have to take the branch. So here you have the number of branches. Okay. That is the multi-way split. Next one is the binary split. Binary split in the nominal attributes. Total attribute values. So, for example, you have to consider the marital status of a particular person. Generally, you have to represent the married, single, divorced. So, here you have to consider as a married is taken as a true, other two is taken as a false. That is the single and divorced. Similar way, marital status single you have to consider as a true, other two married and divorced you have taken as a false. So marital status you have to consider as a single and married. Here you have to take it as a true or false. So divorce is taken as a true. So like this way, we have to represent the binary splits. That is the grouping attribute values. Whenever we have to find out test conditions, we have to apply it for the nominal attribute. Clearly, it shows that that is the binary split, that is nominal attributes. That is regarding to the nominal attributes. So now we have to discuss with that another attributes. So first one is the binary attribute, second one is the nominal attributes. Already these are the attributes we have discussed in the first 10. And third one is the ordinal attributes. Ordinal attributes are there, you can produce binary or multi-way splits. The values can be grouped as long as grouping does not violate the order or property of a attribute values. For example, you have to consider the shirt size, small, large, medium, okay, extra large. So here more than multi-way splits, that is you have to represent it as in previously one value we have to consider as a true or false, and the remaining other two values we have to consider as a false. And at least one of the binary split, one value only we have to consider as a true or false. But whereas here in ordinal attributes, we can produce the binary or multi-way splits. For example, left side you have to taken as a two values, right side as taken as a two values. That is the ordinal attribute. So these can be produced the binary or multi-way splits. The values can be grouped as long as the grouping does not violate the order property of attribute values. So that is a small, medium, large, extra large. Here we have to consider like this. Next one is the attribute selection measures. So once you have to completed the attributes regarding what are the different types of attributes you have to use it in decision tree algorithm. So next one is the attribute selection method. An attribute selection method is a heuristic for the selecting the splitting criteria that best separates a given data partition D of class labeled training tuples into individual classes. So for example, here you have to consider the data partition D is split into smaller partitions according to the outcomes of the splitting criteria. Okay, the best splitting criteria is one of the most closely results in such a scenario. The attribute selection methods is also known as splitting rules because they determine how the tuples at a given node are to be split. The attribute selection methods provides a ranking for each attribute describing the given training tuples. The attribute having best score for the measure for is chosen as splitting attribute for the given tuples. If the splitting attribute is continuous valued, or if we are restricted to binary trees. So here you can see the tree node created with partition D labeled with the splitting criteria. Branches are grown for each outcome of the criteria. So mainly here, three popular attribute selection methods we have to use. Those are, that is the information gain, gain ratio, and Gini index. So here information gain, you have to represent the ID3. ID3 is just the information gain as its attribute selection method. So here information gain, that is you have to represent it as the expected information needed to classify the tuple in D is given by information gain of data tuple partition. We have to is equal to minus of summation of 1 to m p of I log 2 of p of I. By using this formula, you can find out the information gain for the tuple partition, where p of I is the non-zero probability that the attribute tuple D belongs to the class C of I, is estimated by C of I comma tuple partition D divided by modulo of D. The log function to the base 2 is used for because the information is encoded in bits. Information of D is also known as entropy of a D. So easily, what is entropy? They have to call. Entropy means information gain of the tuple partition is simply called it as entropy. Information needed of using the A to split D into the B partitions. So actually, the tuple D can we have to gain the information. If the D is split into the V partitions, how we can find out that information gain of A, that is the split D, is equal to summation of J equal to 1 to B. See here, the summation of J equal to 1 of V 1 to V, the modulo of D of J by modulo of D into information of D of J. So what the information gain for the tuple D that is multiplied with this. So finally, you can get the information gain is defined by the the difference between the original information requirement based on the just propagation of class. So here that is the just because and a new requirement, and that means the original information gain minus new requirement information gain. Finally, you can get the information gain of the particular attribute. So this is the way you can gain the information gain. This is the highest common information gain, that is the gain of A. It's chosen as the splitting attribute of node N. So this is the best classification. This is regarding to that information gain. And the next one is gain ratio. So here, how we can find out the gain ratio? C4.5, the successor of ID3. It uses the extension to information gain known as gain ratio, which attempts to overcome this bias. It applies a kind of a normalization to information gain using a split information value defined by the with the information gain ratio. You can find out like this. Split of information gain of D is equal to minus of J equal to 1 to B, that is the D of J by D of D. That is the modulo, both are modulus we have to present into log base to D of J by D of D. Both we have to module. That is the gain ratio you have to find out. That simply call it as C4.5. So here we can get that split information. The value gain ratio we have to find out. Gain of A, that is the original gain of A, that is the information D of minus information E of D, divided by splitting information of A, that is the D. Splitting information of D, we have to get in the gain ratio. Gini index is used in the part. Mainly you have to represent the impurity of index measure in the impurity of D. The data partition is set of prime tuples. Gini of D equal to 1 minus I equal to 1 to M summation of P of I square. By using this formula, you can find out the Gini index with the values. This is the original Gini index. This is the attribute Gini index for each attribute. Modulus, both modulus of D1 by D, Gini index of D1, and D2 by D, Gini index of D2. Finally, you can get the Gini index. So overall, you can get the Gini index of a particular attribute. The original Gini index minus attribute Gini index, Gini of D minus Gini of A of D. So by using this formula, that is the final you have to, that is the Gini index of value. And a similar way, you can provide the gain ratio. This is the gain ratio of the splitting. Gain index split information of B. And gain ratio of the A information of B, information of A. So this is the way you can find out here. That is the Gini index. Next, trine pruning. Trine pruning, we have to find out when the decision tree is built up of the many branches. When a decision tree is built, many of the branches will reflect the anomalies in the training data due to the noise or outliers. Data pruning methods are addressed. This problem can overfitting of the data. Such methods are typically use the statistical measures to remove the least reliable branches. Pruned trees tend to be smaller and less complex, and thus easier to comprehend. They are usually faster and better at correctly classifying independent test data than unpruned trees. So here pruning work, how you can perform that is in tree. Mainly here you can use the two common approaches for the tree pruning. First one is the pre-pruning and second one is the post-pruning. Tree pruning approach, the tree is pruned by halting its construction early. Upon halting, the node becomes leaf. The leaf may hold the most frequent class among the subset tuples or probability of distribution of those tuples. If the partition is the tuples at a node would result in a split that falls below a pre-specified threshold, then further partitioning of a given subset is the halt. There are difficulties, however, in choosing an appropriate threshold. In a post-pruning, which removes the subtrees from the fully grown tree, a subtree at a given node is pruned by removing branches and replacing it. With a leaf, the leaf is labeled with the most frequent class among the subtree replaced. See this diagram, it shows that is the unpruned and pruned trees. These are the unpruned, this diagram it shows the unpruned trees. This is the pruned trees. So you see here A1 S no. So again attribute S or no. So A1 you have to A4 and class A, again S or no. So here you have to consider this is the unpruned tree. So what are the levels of each attribute is similar. But whereas here in the pruned trees, you have to represent S or no, that is you have to represent it as all or class B. So you can do any other attributes we want to check. Simply you can write the class B. So directly if A1 is S, you can do the class A and class B. And remaining right side all the values are class B. So simply you can use the no purposes, you can write the class B. This is simply you can say that is the non-pruned and unpruned. So you can do the right side of the subtree. So if the S are no for the every attributes, that is A3 and A5. So class B, here also you can get the S or no. S purposes you get the class B, no purposes also you can get the class B. Similar way you have to get. So you can do all these things, simply you can write class B. This is the pruned trees. The cost complexity of the pruning algorithm used in a court is the example of the post-pruning approach. This approach considers the most cost complexity of a tree. The cost complexity of the pruning algorithm used to cart is an example of post-pruning approach. So here, that is the pre-pruning approach as well as post-pruning. Pre-pruning means simply you can construction early. Post-pruning simply you can remove the subtrees from the fully grown. So actually this is the pruning and pre-pruning and post-pruning. So unpruned and pruned trees. The cost complexity of the pruning algorithm used to start is an example of post-pruning approach. This approach considers the cost complexity of a tree to be a function of a number of leaves in the tree, the error rate of the tree, it starts from bottom of the tree. Simply, you can say that a pruning set of a class table triples used to estimate the class complexity. This set is independent of the training set used to build the unpruned tree of any test set used for the accuracy estimation. The algorithm generates the set of the progressively pruned trees. In general, the smallest decision tree of the minimize the cost complexity preferred. P4.5 uses the method called pessimistic pruning, which is smaller to the cost complexity method. In that, it also uses error rate estimates to make the decision according to the subtree. Scalability of the decision tree reduction. So that is the here you can decision tree algorithm side is P4.5 and cost. So this is the ABC set subset. This is a example. First, we have to consider for the cutout decision tree conduction and the classification rules we have to generate for the data set. See here, this is the example. Age of the people, what are their income, and students, and credit ratings. He buys the computer or not. So already this example we have to discuss in so far in previous classes. Whenever we have to discuss with that. This is a solution of the information gain for the given data. Buys the computer, how many people are there, how many computers are no. So that is the totally 9 S's. Buys the computer, we have to represent the 9 and no is 5. Totally 40. Information gain of 9, 5, you can get the value that is the 0.940. Similar way, you can process all these things, you can get the value. Information gain of this one with the new attribute, that is the middle age, you have to consider. You can get the 0.6 value. So the total gain of the age is you can get the 0.940 minus 0.690. You can get the 0.247. This is the information gain. Then gain of the student. Like this way, you have to find out. Finally, that is the age has the highest information gain among the attributes. It is selected as a split node. Node n is labeled with the age. All branches on each of the attribute values. So age, youth, middle age, age single. Here, this is the diagram for the splitting branches of the tree pruning. Here you have to represent these are the classification. Okay. First, constructing the decision tree. Then you have to represent the classification rules. This is regarding to that third unit. In next class, we will discuss in the fourth unit. See here once. See here, this is the fourth unit regarding to the data classification, alternative techniques. So in the previous unit, only we have to discuss what is the data classification and what are the and what is the decision tree, what are the algorithms you have to use, or decision tree algorithms you have to use, what are the mainly what are the approaches you have to follow, information gain, index. So these all things you have to discuss it in the third unit. The fourth unit mainly we have to discuss with that Bayes theorem and Bayesian classification, Bayesian belief networks. So only these are the concepts you have to discuss regarding to these alternative techniques of classification. So classification, simply you can say that it is a form of data analysis that abstract the models describing import data classes, such as models and called as classifiers, predict the categorical class labels. Example, we can build a classification model to categorize the bank loan applications as either safe or risky. Such analysis can be helpful to provide us with a better understanding of the data at large. Many classification methods have been proposed by the researchers in machine learning, pattern recognition, and statistics. Classification is alternative techniques and the Bayesian classification. Bayesian classifiers are the statistical classifiers. Then we can predict that class membership properties, such as a probability that a given tuple belongs to a particular class. So Bayesian classification is based on Bayes theorem. So here the Bayes theorem, generally you know that probability of values, conditional probabilities mainly have to be represented in Bayes theorem. So how the conditional probability you have to apply for the given this taking this data, and you have to apply the conditional probability. So what is the values we are getting? You can by the computer or by the computer, no, you can get the values. This is the advanced methods. We'll continue in next class.